Hi, welcome back to Science 1206, the Sustainability of Ecosystems unit. I'm Ms. Ledwell, and in this video, we'll talk about biodiversity and resilience. Let's get started. Biodiversity can be defined as the number and variety of organisms found in a specific region. The prefix bio means life, and diversity means variety. Biodiversity also includes the variety of Earth's ecosystems. Biodiversity is a key indicator of the health of an ecosystem. To ensure the sustainability of ecosystems, it is essential to protect the diversity and abundance of organisms, thus preserving biodiversity. Biodiversity is also vital for ecosystem services. Ecosystem services are the benefits sustainable ecosystems provide that are experienced by living organisms, including humans. Some examples of ecosystem services include forests taking in carbon dioxide and releasing oxygen, which organisms like humans need to breathe, the pollination of plants by pollinating insects, soil fertility, and the production of food, fossil fuels, timber, and medicines. In ecological terms, resilience refers to the ability of an ecosystem to maintain its functionality and stability despite experiencing disturbances. So examples of disturbances are things like flooding, fire, and drought that affects parts of the ecosystem. Ecosystems with high biodiversity, characterized by a wide variety of species, generally demonstrate greater resilience than ecosystems with lower biodiversity. Let's look at some evidence of the relationship between resilience and biodiversity. Minnesota scientists conducted experiments on numerous growing plots with 1 to 24 native plant species per plot. As a result of their experiments, they found that more species in a plot led to higher ecosystem efficiency. Plots with more species produce more biomass, that is, the total mass of living organisms in a given area at a given time, so they were able to trap more carbon dioxide gas. Higher species diversity increased nitrate consumption, reducing potential toxicity to surrounding ecosystems. Diverse plots were better at resisting invasions by non-native species. And increased diversity correlated with reduced disease incidence. The Minnesota scientists' experiments highlighted the benefits of greater biodiversity for ecosystem resilience. Let's look at some graphs of their experiment. In the first graph, we have plant species diversity on the x-axis and total plant cover on the y-axis. You'll notice that as the species diversity increased, the total plant cover also increased. Our next graph shows plant species diversity and the number of invasive species. So on the x-axis we have plant species diversity, and on the y, the number of invasive species. So you can see as the diversity of plant species increased, the number of invasive species decreased. And the last graph we're going to look at is plant species diversity and disease severity. So we have plant species diversity on the x-axis and disease severity index on the y-axis. And you'll notice when plant species diversity is low, so you have between 0 and 4 types of plant species, the disease severity index is high. When the plant species diversity increases, so we have more diverse species of plants in the plot, then the disease severity index decreases. Now it's time to continue to the next video. Before you do, pause for a half-minute recharge. Rise, reach, and stretch before moving on to the next video.